For as long as we've been human, we've stared at the stars and asked one simple question: are we alone? We've been searching for radio signals and spying on distant planets, but what if the answer is right here in our own solar system? I'm talking about a moon orbiting Jupiter called Europa, and scientists believe that beneath its frozen surface lies something insane, a saltwater ocean that's been there for billions of years. But reaching it means flying straight into the most dangerous, radiation-filled place in the entire solar system. In October 2024, NASA launched its most daring mission ever. A $5 billion spacecraft, the Europa Clipper, started a 1.8 billion-mile journey to figure out if this icy moon has what it takes to support life. This is the story of a mission to an alien ocean, a mission with incredible promise that faces nearly impossible challenges. The question isn't just if we can get there anymore, but what we're going to find when we do. To get why the Europa Clipper mission is such a huge deal, you have to understand why Europa is so special. I mean, at first glance, it's just a small, icy moon. But decades of clues have painted a wild picture. We have strong evidence that under its icy crust, which might be miles thick, there's a global ocean of liquid salty water. And we're not talking about a small puddle. Scientists estimate this secret ocean could have more than twice the amount of water in all of Earth's oceans combined. Just think about that. Every single ocean on our planet, doubled and hidden on a moon hundreds of millions of miles away. An ancient ocean that big is a game changer because here on Earth, wherever we find water, we find life. For life as we know it, you basically need three things. First, liquid water. Europa seems to have that covered. Second, you need the chemical building blocks of life, things like carbon, hydrogen, and oxygen. And third, you need an energy source. The crazy thing is, Europa might just have all three. It's this trifecta that makes it the single most compelling place in our solar system to look for life right now. The potential is so massive that NASA is dedicating its first ever mission specifically to this one moon. But everything we think we know is based on evidence from far away. So how are scientists so sure there's an ocean they've never even seen? The story of how they figured it out is some next-level detective work. The first clue that Europa was more than a dead rock came from the Voyager spacecraft back in the 70s. The pictures were fuzzy, but they showed a surface that looked weird. Instead of being covered in craters like our moon, it was smooth, bright, and crossed by these huge, dark cracks. It looked young, like something was happening underneath. Then, in the 90s, the Galileo spacecraft got a much closer look, and its pictures were stunning. They showed these bizarre, jumbled landscapes called chaos terrain, where it looked like the ice had broken apart, floated around, and then frozen back together. It looks almost exactly like sea ice breaking up over Earth's oceans, which suggests the ice shell is just floating on top of a liquid layer. More recently, the James Webb Space Telescope found carbon dioxide on the surface, a key ingredient for life. And here's the kicker. It was most concentrated in one of the youngest areas of that chaos terrain. This is a huge hint that the carbon is coming up from the ocean below, giving us a direct link between the surface and the hidden sea. But the biggest piece of evidence, the smoking gun for a liquid ocean, came from Galileo's magnetometer. Jupiter has a monster magnetic field that spins around. As this field washes over Europa, it should cause a reaction. And Galileo found one. It detected a weak magnetic field coming from Europa itself, one that was changing perfectly in sync with Jupiter's. The best way to explain this is to imagine you're on a beach with a metal detector. The detector sends out a signal, and if it passes over something metal, the metal creates its own little magnetic field that the detector picks up. In this story, Jupiter is the metal detector, and the signal Galileo found was the ping of a massive electrically conductive layer inside Europa. And the best-known natural conductor that big is a global ocean of salt water. On top of all that, the Hubble Space Telescope has seen what might be giant plumes of water vapor shooting hundreds of miles into space from Europa's surface. Later, scientists looking at old Galileo data realized the spacecraft might have flown right through one of these plumes back in 1997 without even knowing it. If these plumes are real and they come from the ocean, they're like free samples, giving us a way to taste what's in the water without ever having to drill through the ice. With so much evidence, the mission is obvious: go to Europa. But this is where the incredible promise meets a brutal reality. The challenges are just insane, starting with the distance. Europa Clipper is on a 1.8 billion mile, 5.5-year journey just to get to Jupiter. It launched in October 2024, but it won't even arrive until April 2030. But the distance is the easy part. The real villain of this story, the main reason this is so hard, is Jupiter itself. The planet's magnetic field, the same one that helped us find the ocean, also creates the most intense radiation death trap in the solar system. Jupiter is a giant particle accelerator, trapping and slinging electrons at nearly the speed of light. To say this environment is harsh is a joke. It's a storm of high-energy particles. An unprotected astronaut would get a lethal dose in minutes. For a spacecraft, this radiation tears through its skin and fries its electronics, causing glitches, corrupting data, and eventually killing it completely. And Europa, our main target, is right in the middle of the worst of it. This creates a huge problem. To study Europa, you have to get close, but getting close means flying through a storm of radiation that will destroy your spacecraft. A mission that tried to just orbit Europa directly would be fried before it could even get started. This lethal radiation is the biggest challenge, but there are others. The spacecraft has to work in freezing temperatures, far from the sun. It has to send signals across hundreds of millions of miles, with a huge time delay. And just to get it going, it needed a SpaceX Falcon Heavy, one of the most powerful rockets on Earth, to launch the 14,000-pound spacecraft. To survive all this, NASA had to build one of the smartest spacecraft ever. To beat these challenges, NASA's engineers at JPL designed the Europa Clipper. It's the biggest interplanetary spacecraft NASA has ever built for a planetary mission. Its solar arrays are over 100 feet wide, the length of a basketball court, just to soak up the faint sunlight out by Jupiter. First, they solved the radiation problem. How do you study a moon you can't safely orbit? The solution was genius: don't orbit Europa at all. Instead, Clipper is in a long, looping orbit around Jupiter. Most of the time, it's far away from the worst radiation. But on each lap, its path is perfectly aimed to perform a quick, high-speed flyby of Europa. It's basically a dip-and-run strategy. Over its mission, Clipper will make 49 of these close passes. It'll dive in, get as low as 16 miles from the surface, collect a ton of data, and then swing back out to safety to send it all home. This orbital dance dramatically cuts down the radiation exposure, letting the spacecraft survive long enough to finish its job. But even those quick dips are dangerous. To protect the electronics, the spacecraft's brain, its computers and processors, are locked inside a radiation vault. It's an armored box made of nearly half-inch thick titanium and aluminum, designed to block the killer particles. With its survival plan locked in, Clipper can get to work with its 9 cutting-edge instruments. Its most famous tool is a radar system called Reason. It's designed to do what we've only dreamed of: see through the ice. It will bounce radio waves through the shell to map its thickness, find hidden pockets of water, and try to detect the top of the ocean itself. This instrument is planned to be tested and calibrated during its flyby of Mars in February 2025. Another instrument, a powerful magnetometer, will measure Europa's magnetic field with way more precision than Galileo. This will help confirm the ocean is there and figure out how deep and salty it is. High-resolution cameras will map the surface in incredible detail, looking at the weird reddish stuff in the cracks to see if it's organic material that has bubbled up from the ocean. Finally, a thermal imager will look for hotspots, which could be areas where the ice is thin. And other instruments will be on the lookout for those water plumes, ready to fly through and taste their chemistry, giving us our first direct sample of an alien ocean. It's important to remember what this mission is and what it isn't. Europa Clipper is not designed to find life. It doesn't have tools to look for alien fish. Its job is to answer a simpler but just as important question: is Europa habitable? Does it have all the right ingredients, water, chemistry, and energy in a stable environment where life could survive? Clipper is like a scout, mapping an unknown wilderness. It's looking for the best places to search, the spots that future missions could one day target with a lander that drills into the ice. It's the first critical step in a search that could take generations. For thousands of years, we've looked up at the sky and wondered. Now, we're living in a time where we can do more than just wonder. We can build explorers and send them across billions of miles to get answers. The Europa Clipper, a masterpiece of human engineering, is now flying silently through space, carrying all our hopes with it. The secrets of Europa's ocean are still locked away under miles of ice. But in 2030, we're going to start knocking on the door. And what we find could change everything we know about our place in the universe. The first data from this incredible mission won't get back to us until 2030, and we'll be covering every discovery. The story of Europa is just getting started. If you want to come along on this journey, make sure you subscribe so you don't miss our updates on what Europa Clipper finds.